Hello, this is the Bagenaudier puzzle. The aim is to take all of these rings off. As you can see, they will not come off by themselves. This is a hard puzzle, but today I will show you how this is solved. This may seem easy, but it's actually quite complex. One of these with just 8 rings takes 170 moves. This has got 9 rings. This puzzle has roughly around about 300 moves in it.
The internet's down here.
I'm filming. The whole family has tried this puzzle and all have failed, but one. I think it's quite obvious what that person is. I probably haven't even done 50 moves. This puzzle may just look like a puzzle, but it actually has quite a lot of mathematics behind it, so I won't explain it all in this video, but there's quite a lot. This puzzle can be bought online, and it's quite fun once you get it solved. What's very, very interesting is that there are many, many other puzzles which are very, very much like this. They have the exact same mathematics behind them and the same solution. This puzzle is not just called the Bagenaudier, it can also be referred to as the 9 rings puzzle or the Chinese rings puzzle. This puzzle is quite a very confusing puzzle, and like there's many ways that you can get lost by doing this puzzle, and the solving can get tangled in there. It's do not try this at home, as you're probably going to get the embarrassment of
341 moves, I think it was.
yes, this puzzle actually has 341 moves. And if you ask me, it's a lot. Please like this. And this is not even finished. It's like there's still quite a lot more to go. Please like and subscribe. I might be halfway. I've probably got another 100 moves to go, maybe 170.
It's 7.5 minutes. Keep going.
If you think this is a long video, it is. Okay, now we've got another maybe maybe 80 weeks ago.
How long did it take you to figure out how to do it? First time?
Well, after I got this other puzzle. It's called the brain puzzle, and it's got the same mathematics and the same solution, and it's composed of 8 stick with pegs, and the aim is to get all the pegs sticking outwards. And I solved that puzzle first, and then from that puzzle we picked another puzzle called the spin-out puzzle, and then I solved that one. And then came another Bagenaudier. And then from that one I solved this one. And then I solved that puzzle as well. And then finally came this puzzle. So, and roughly, because I knew so much about the mathematics of this, it was quite quick to get the hang of it. So, if you ask me, maybe one or 2 days. On first time solving it though, took about 2 hours. please like and subscribe to this video if you like puzzles like me.
Can you say a few words about the maths?
Well, yeah, there's quite a lot of math, but I guess I can explain a little bit. The math composes of a series. With my dad, we spent an afternoon looking at the maths behind the puzzle. And first thing we looked at was how many moves, depending on how many pegs that we're trying to put down. And we came up with an infinite series, which went like this: 1, 3. No, it went 1, 2, 5, 10, 21, and then 42, and then so on and so forth. And with this series we came up with a formula. And I won't say how we explain that formula because I'm sure that all the viewers would get extremely bored and would probably instantly stay away from their computers for months. But I'm just going to say the end formula. We came up with a formula that went like this. It was what was it? N
2 to the n.
2 to the n
Plus 1.
plus 1 over 3.
Minus 2.
Minus
2 over 3.
Sorry. N 2n minus 1 divided by 3.
2 to the n plus 1's power.
Yeah, 2 to the n plus the 1's power. Plus the 1's power. Sorry, I'm a little bit rusty on the formula. Yes, and we also came up with another series, got to do with the actual moves themselves. And I'm not sure if any of you have heard of binary. Binary is a series I can do with my hands, but my hands are a little full right now. But binary is a computer language comprised of zeros and ones. And now look, binary, it changes, I'll just give you some numbers in the binary series. 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, and then 1, 1, 0, and so on. Now, with this series, you may have noticed that 2 of the digits are changing sometimes, even 3 in some cases. And that does not match this puzzle, as you can only move 1 peg at a time. But, very coincidentally, there is another series based on binary called Grey Code, or Grey Binary. And in this series, only 1 coefficient changes. So if we write down all of that, and we write down the corresponding peg, you get a step-by-step instruction manual.
So,
And hey presto, solved. Now I'll just show you binary on my fingers. So this is binary. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And there's also many other bases.
and how do we convert that to grey code?
Okay. Now, because I said previously that grey code was based on binary. Now you may be wondering how do you get from grey code to binary? Now to do this, another concept must be understood. Logic gates. Now there are many different types of logic gates: OR, AND, NAND, NOR, XOR, and so on. And there's quite a lot. But the XOR is the one that we use. We write down a 1, and then we take the two numbers, so two successive numbers, two successive coefficients of binary, and then we put them both through an XOR logic gate. And then we get the number that the logic gate gives out, and then we write that down. Logic gate is a 2-input device that gives out 1 output. Thank you.